Okay, I'm Mariano. I'm the head of engineering of C Labs. I'm probably going to try to fast forward the first few slides because I wanted to talk more on the technical part. So last year on HCC, we actually announced that we wanted to go to Celo layer 2. It took us actually a while to figure out how, because we had an initial idea, then we start basically having to analyze all the different frameworks. But almost recently, a week ago, we launched our first testnet. I guess the merits of this testnet, to me, mostly it revolves about migration. Like, it's actually one thing to launch a layer 2 on your own, like you start from scratch, you don't have any state. But a very different thing is to launch using like an existing chain. And Dango in particular is actually a fork of one of our oldest testnets, Alpha Horus, which has been there for 4 years. So it's basically 4 years of history that we are migrating. And so in a way, like, yes, you get the best of Celo, and now it's available on a testnet. And I guess we see how Ethereum is becoming like this settlement layer for Web3. It's like, that's the whole idea of actually Ethereum roadmap. And you see how all these layer 2s and rollups are appearing and trying to use Ethereum as a settlement. And I guess we hope that Celo, as one of the first, if not the first, ones that's basically migrated into L2, can basically pave the way for others to follow. So what I want to talk here is about like how to do that. You know? I guess what I'm trying to say here is like, yes, this is actually quite a hard fork. What I mean by that is like, basically, you need to imagine, like, imagine you are a user, you have your wallet, or you have a dApp, and you go to a dApp. The moment a Celo transitions to an L2, it's going to be just another block. So you're not going to notice that. You are going to see that, okay, there's L1 blocks, and then the next block happens to be an L2 block, and nothing really happened. It's like any other hard fork, no? So whenever you had a hard fork, yeah, there's protocol changes. Maybe there's a new transaction type. There's AIP 1559 or things like that. But in general, it's the same thing. And here, it's going to be the same thing. Of course, for node operators, they need to do something. So 5 tips on how to migrate to an L2. So first tip is like, use an existing stack. No? Again, if we see this whole idea that we are going to have several L2s going to L1, and we see all this kind of, we are getting into this fragmentation problem. We're going to have a lot of L2s, and actually it's best if we start trying to standardize things. No? Like, I guess the whole idea of being modular, having like these things, it's like, okay, you need to reuse these things and don't go solo. No? In our sets, we basically chose OP and Eigen. I guess for OP, I guess the tweet talks a lot by itself. No, you can see like around like 74% of L2 throughput is actually powered by OP. And why? I guess that's not just luck. No, it's like what is happened here is like, I think OP was created to be a stack, no? So has been created to be a stack. And that actually matters because when you see the whole design, the whole like code, you see that it's actually very well like structured, modular, and separated into parts. So it's actually very easy to extend. It's also, that's why I guess because you have all these projects, you have a very big open source community, which at the same time means that you're going to have like probably different options. Now, if you want to use DA, well, definitely you can probably go to find example of EigenDA, or you're going to find example of Celestia or Avail. If you want to choose whatever you want to choose, you're probably going to find examples of that. And I think another nice thing to say that I guess maybe you don't find that very often, it's actually very well spec. So if you want to learn how it works, you can actually go there and actually going to see a step-by-step detail of actually how things are being like created there. On Eigen, I guess, for us, basically, what most important thing is like we want this kind of off-chain data availability for Celo and Celo users. Having very cheap fees, it's actually very important. And I guess on that, I think there's many options that are all very good options. Something I guess we like also was like this kind of idea of power risk taking. So Eigenlayer has risk taking, and to us, I guess to me, that's actually quite nice. I guess there's some economic reasoning about how risk taking works. I think there's like some kind of social part of like, okay, you have the same actual entities running the same things for you, and I guess that's probably not captured in the protocol in the economics, but I think actually has some social value. So now, tip number 2, I guess I'm going too fast, but distill your protocol into a patch queue on top of your stack. So 2 parts here. First, distill. No? So yes, you probably, I guess Celo has like more than 4 years of history. We created some features, and the moment you are going to a 2, I guess it's actually a perfect moment to try to distill your protocol. Basically to try to see, okay, let's keep all those things that are really, really important and leave the other things apart. No? So do that process. Second thing is like patch queue. I guess also if you've been solo working for more than 4 years, you probably know that, or any other blockchain company, and if you depend on OP stack or Geth or whatever, well, you have a huge engineering problem. It's like you need to do upstream merges. Basically, you need to bring the code from Geth every now and then to keep up to date. So that's actually quite challenging, quite error-prone, and quite a problem, no? And so in that sense, I think like the best thing for you to do is to try to have your features be layer on top of the stack of your chosen as a patch queue, no? If you know about Git, like as a patch queue. Even better, if you can get your features integrated into a stack, because that will, first, you're going to contribute to a stack back, which is a very nice thing to do, and second, you're going to have less a problem doing upstream merge. So for us, a few features that kind of demo this thing, no? So Celo has fee abstraction. The idea is like you can pay gas fees with ERC20s. And currently, for example, you can pay with USDT, with USDC, and with like Celo natives. And this is very powerful for us, I guess, for our users, because what we want here is like, imagine you want to go and do payments, you want to do things like that. Well, it's kind of hard to explain that you need to do that with like some other token that is not your familiar token, like Celo, ETH, or whatever. A kind of abstraction is going there, but I think it's not that simple yet. No? So for us, how you do this? So we do this with envelope transactions. No? I know if you know EIP 1559, the idea is like you have this idea of, well, it's an envelope transaction. There's another EP that creates this idea of where you can have transaction types. These are called envelope transactions. And to me, actually, the perfect way for you to extend a protocol. If you want to extend Ethereum, try to do it in a way where it's going to be isolated. No? And I guess envelope transactions are very good to do that. So in our case, we basically add a field where you say, OK, what's the address of the ERC20 you want to use? And then the state transition function is going to handle that for you. Another big thing is like one block finality. Here is not much of a change. It's more of a realization that I guess not many people do. So people like to see like, I guess L2 has like one block finality, have 1 second blocks and say, okay, yeah, this is very fast. It's not really that way. The problem you have is like, for example, OP, when you have a block that happens every 2 seconds, that block first doesn't go to Ethereum. It goes to Ethereum a couple of seconds later or minutes. But also, it's using information from Ethereum blocks. So when they basically do deposits or what they call forced transactions, they're basically using information that is in Ethereum blocks. Now, Ethereum blocks are not final until 15 minutes after. So if you use things that happens before those 15 minutes, then in the chance that Ethereum can reorg, and actually Ethereum like basically doesn't reorg after 15 minutes, but there is a chance that it do, like the moment that there's a proposer or testers, well, your whole chain will need to reorg. So actually, if you want to have one block finality, what you need to do is like, well, you need to rely on Ethereum finalized blocks. That's actually, for OP, likely is more of like a configuration thing. And that's one thing you need to do. I guess you're going to have slower deposits. It's going to take 15 minutes, okay, but what you're providing is one block finality. You are not going to have reorgs. The other thing you want to do is like try to add slashing for equivocation. So sequencers are going to say, hey, there's a block every 2 seconds, but how we know that actually is going to happen? Well, I guess right now maybe it's reputation. They're not going to do things that they are against themselves and their brand, but maybe you can also add like a slashing or have a testers. Another feature that Celo has that also shows something that extension is like token duality. So Celo, it's a native token of our Celo network, but at the same time, it's an RC20. It's dual. Now, that seems like a dream, like we've all heard like a wrap F and all those kind of things. So this is interesting to be done. And it's actually easy, but has like you need just like very simple hack, which is you need to be able to implement the transfer from of an RC20 interface. And that means you need to be able to transfer on behalf of someone else. And for that, actually, you need a precompile. So we have a simple precompile that only that contract can call, and that kind of solve the problem. Again, precompiles is probably another thing that you can actually do and extend, and it's fairly straightforward. OK, tip number 3, migrate your chain versus porting your code. So if you have a chain that has been there for 4 years, and you probably have a few hard forks, a few protocol changes, maybe those changes are on the block format, on the block header, on the type of transactions. So when you are going to an L2, you are basically creating this new client. Do you want to port all that code? You probably don't. And so what you could try to do is be able to migrate the history. And what I mean by that is actually when I run an L2 node for Celo, this node has in their database all the blocks from Celo since Genesis 4 years ago. And it needs to be able to read them, it needs to be able to interpret them, it needs to be able to validate them. And for that, it needs to know how they are actually spec. So what we actually did was basically migrated those blocks while keeping the block hashes and all the information of them. And that kind of gives you kind of the best of both worlds. We still need to port some code. So for example, we had envelope transactions that we don't use anymore. We still have them. We also have like what we call like a Celo native transaction, which was like a transaction before EIP 1559 that had this feature of fee abstraction. We also had to port that. It's just to be able to read those blocks. But that's one thing. The other thing you need to do is like handle archive nodes. So yes, you have a full node, but archive nodes has this ability to be able to query historic state. You can go and query the smart contract state like somewhere like 2 years ago, and that's an archive node. Now, the problem is that to do that, well, your L2 node won't have that feature. And of course, because it's not, you would need to migrate everything, and that would be a big pain. But what I can do is actually proxy that. So it's not ideal in the sense of like infrastructure runners, but it actually works pretty well. What you do is like you have your L2 archive node, which is able to respond all state queries for the L2 state, or L2 history. And then whenever it receives like a tracing call, an if call for a very old block, well, you defer that, you proxy that to a L1 archive node, And that way you can solve it. OK, tip number 4, it's like, so rethink where your token lives. So Celo, it's a native token of this L1 going to an L2. Now, the moment you be an L2, you have this question. Do you want Celo to be a native RC20 of Ethereum, or do you want it to be like still then only exists on the L2 and only bridge Celo back to Ethereum whenever you need? Because we chose the first idea. Why? I guess having an RC20 on Ethereum will have better security. And so, but that kind of creates a problem because you already have all this token supply already on the L2. How you make that? And so it's also straightforward. What you can do is basically you just like mint all the Celo on the L1. You lock that on the native bridge, and then that means that everyone can withdraw their Celo native on the L2 back to Ethereum, and that will just work. We have a small or not small caveat, which is what happens with minting and burning. OK, 5 minutes. What happens to minting and burning? So for minting and burning, what you need to do, well, probably, I guess, minting and burning actually happens on the Celestia network, right? Right now, for example, you have epoch rewards, things like that. And so I guess what we found so far is that, okay, we can like mint the whole total supply that we know that it's capped to 1 million. We put it on the bridge, and then we replace minting by releasing. So we have a contract that basically locks all the Celestia that is to be minted, and it's going to release it using the same minting schedule, but now it's going to be a release schedule. Like if you think economically, it's basically the same thing. Okay, tip number 5, and I'm finishing with this, do multiple upgrades. This is more of like an engineering practice, but I guess it's pretty obvious, right? If you have these very, very complex things to do, and if you know from infra, you have this idea of continuous delivery. Basically, you want to always be shipping things and always be basically doing things. So try to do this exercise multiple times. In our case, what we are thinking is, so this is Django right now, so we had 2 testnet, Alfajores, Baklava, and 1 mainnet. All these are kind of like public testnets or chains. So our first experiment, real experiment, was like, okay, we're going to fork Alfajores. We're going to basically use the same state history of Alfajores, and we're going to create a new chain. That's Django. That happened like Friday. Later, we're going to basically upgrade Alfajores. What it means is like you have like, I don't know, your Infura or Forno or whatever RPC URL you have for Alfajores. It's still going to be the same. It's just going to be replaced to node to node, and you won't notice a difference. Then we're going to do with Baklava. So Alfajores will run entirely, but Baklava is actually run by a whole like validator set. So it's going to be much more of an orchestration project where we need everyone to do the upgrade themselves. And finally, we're going to do mainnet. The idea, again, is to exercise this muscle of doing the migration as many times as you can. Okay, that's all for me, and I guess I finished almost on time. Great.
I'm just wondering what was like the biggest motivation to move from an L1 to an L2? Like what?
Yeah, great question. I guess I have my personal view on the subject, which is like, to me right now, if you are a chain, you might be an EVM chain or an AVM chain. And I think Ethereum has demonstrated that they are like the biggest chain out there on EVM. And if you're an EVM chain, you're basically trying to be almost like them, right? So you have 2 choices. One choice is to be truly, truly different. And then like that means follow the path of like Aptos, Solana, Suin, have a very different model, maybe try to capture a different side of the market, by having other use cases. Or you should basically join the community in a sense and be part of the grander Ethereum community. If not, you are kind of like in the middle, And so to me, that's from like a more like a I guess strategy perspective. From a technical perspective, you also going to be able to inherit Ethereum security. You're going to have faster or better connection to Ethereum. So there's like definitely benefits there. But again, if you think from a more of like a rational strategy perspective, I think it kind of makes sense to be closer to what you actually want. And actually, a lot of what we say when this style and everything is also going to try to move closer. As something that we find out also the hard way is like every time you try to innovate and try to do something different to Ethereum or faster, like I know, we implement EIP 1559 before it was actually implemented in Ethereum. Well, it later happened that they implemented that in a slightly different way. And so now you have an incompatibility problem. And so it's kind of an interesting thing to say how you make those bets. Like if you want to do something different, you're going to, let's say now you want to do native account abstraction, that's great. But probably by the moment Ethereum has that for EOS, it's going to be slightly different, and then you're going to have a problem. So it's a nice trade-off to think.
Got it. That's clear. Thank you. Thank you very much.